All right, so let's go ahead and let's get started, folks. Um, I hope everyone is doing okay. I know it's been crazy the last few days. So much happening, not only locally with us, but nationally and internationally. I know it's a lot to take in. Take care of yourselves, and let's try to keep safe and keep yourself healthy. Yet I think that the opportunity here to start class again and be able to try to do some work in terms of our classroom, do some chemistry work. My hope is that we can bring some sense of normalcy back, however much we can. And so, what I'd like to do then is to go over with you kind of what we will be doing in class now that we can't meet in person. We'll try to make sure that we can try to cover as much material as we can in the time frame that we have. We'll see how things get along. We'll see how far we can get with this. But I would like to make myself available to you as much as possible. And so I'll explain to you towards the end here. Uh, my availability for office hours will still be the same. And make sure then that if you have questions, if you have concerns, let me know. Send me an email, make comments on the Google comment section. Let me know how things are working out for you, and we'll work things out. Okay. So let's go ahead and let's get started. I think the sooner we establish a routine, I think the better it will be for us. Obviously, as we start out, things aren't going to run very smoothly, but I think with your feedback, make sure you let me know how things are. Make comments in the Google Classroom, email me. I think with your feedback, we can make this thing work much more smoothly. Okay. All right. So first of all, let's start with the daily schedule. I'm sorry. One more thing. I'll try to. I'm going to be running the class pretty much the same way that I ran it at school. I'll start out with any announcements that we have. I'll make sure you'll know about what's coming up. Also, what I'd like to do is I want to try to keep the lecture material down to about 20, 25 minutes, which will give you time to do the work that I'm going to ask you to do. And so, again, that's my goal, to make sure then that I can meet up with that time frame. Okay. Okay. So what you have in front of you right now is the schedule. I think you got an email about this before earlier already, but there's no rotating schedule. We start with period 1 and with period 6. So depending on when I meet you with period 2, I'll start with you at about 9 o'clock. Period 3, a little after 10, and then period 5 about 12:25. Okay, so that's the time frame that I will be posting these videos for you. You'll be able to work, for example, for period 2. You'll be able to watch the video, do all the work that I ask you, and be done with it by 9:52. All the work that I'll ask you to do, and all the work that you'll be doing with me through these videos, will not go beyond the 50 minutes. And so what you'll do is at the end of the period, you'll submit the work through Google Classroom, and that'll finish out our period. That's how I'll take attendance, to make sure that you have been doing the work. That's also how I'll make sure that you've watched the videos, and that you somewhat understand hopefully the material, and any part of it that you don't understand during the video, hopefully you will be uh, commenting in Google Classroom, asking me questions, or meeting with me after school to ask your questions then. But the work that you'll be doing will fit within the 50-minute time frame for each period. And so, for example, period 3, we start at 10:05, and you'll watch the video, get all the work done by 10:55. And for period 5, you'll start to work at 12:25, and you'll be done by 1:15. So I've planned it that way, and I hope it's going to work. So that's the schedule that we're going to be using for the time that we have online. And like I said, I think it'll work out for you. Okay. What we'll do is you'll start out the day by logging in, start out the period by logging in Google Classroom. You'll make sure then that the Ed puzzle will be posted there. We've you're familiar with Edpuzzle, you've used it before. That's why I'm going to continue to use this platform to help you with obtaining the material. I will be making the lecture videos and posting them Edpuzzle for you. So go to Google Classroom, make sure then that you click the link to the Edpuzzle video that you'll have to watch for that particular period, and then start watching the video. Okay. What we're going to do then is I'm going to continue to do the class problems, the problems in the class problem set. And what I'm going to ask you to do, and which is what I ask you to do in class anyway, is that you will write down the problems, you will answer the problems, I will work out the problems for you, and that way then you'll understand how to do the problems. Okay, so what I would ask you to do that's a little bit different though is I'm going to ask you on a separate sheet of paper, and I'll demonstrate this for you in just a moment. On a separate sheet of paper, you will actually work out the problem the way that you think it'll should be worked out. Then you'll copy the problem down the way that I've modeled it for you, and then you'll do that for all the problems that we do together in class during our period here. And then what you'll do then is towards the end of the video, towards the end of the period, what you'll do is you'll submit that work that you did for me, that paper that you worked on. You'll submit that through Google Classroom, very much like how you submit your homework, and then you'll be done with the period, and you'll get credit for the work that we do, the work that you'll do in that period. Okay, so you'll do this after the video is complete. And again, I will show you how you'll do it in just a moment. The next couple of slides will show it for you, but make sure you keep in mind that's how I will make sure that you are following the video and that you understand the material that's being presented to you in the video, and that if there's any gap in your understanding, I'll be taking it up with you on an individual level. Okay. So all that work has to be submitted to Google Classroom before the end of the class period. And so if you look on on Google Classroom, the due date will be the same day, but the time then will be at the end of the period. Okay. So just make note of that. Okay. All right, so let's go ahead and take a look at an example. For example, if this was a problem on your class problem set, it'll ask you, what time does first period start? What'll happen is at this point, I would then pause the video, give you an opportunity to write down your answer to this question, and then input that into Edpuzzle. Once you're done with that, then go ahead and submit, and the video will start running, and then you'll check your solution, your answer with the solution that I give you. So for example, what you would do then is you would write down your answer, and I just want to go over this with you really quickly to show you how you will label your paper that you turn in. So there's a separate sheet of paper, what you would have done here. So let me go ahead and put this on. What you have done here then is make sure then you have your name. Make sure you write your name at the top. Write your name. So let me go ahead and put ink in here. Okay. Write your name at the top. Write your period number and your class at the top as well. Write down the day, the day and the date. Okay. And then label class problem number 1. As you see, I've done that as well. I've labeled the class problem number 1, and I've written down my answer to the question. The question was asked of me, and then you would input this answer into Edpuzzle, okay, and then hit submit, and then you will get my solution. Okay, and so what I would do then is I would give you my solution. So I'd work it out, and here it is. This is the answer that I would give you. That's the solution. That's the correct answer. Okay, and then what you would do then is on your paper, you'd write down the solution that we've done in class here, and then you would write down the correct time as well. So this is the answer that you would give as the in-class solution, the solution that I have given you. Okay, and then what will happen is you'll do this same thing for all the problems that you'll be working on, and then you'll submit this paper here. You'll submit this. You'll take a picture of this. You'll scan it, whatever you have to, and then you'll submit it through Google Classroom. Okay, so very much like how we deal with our homework, but this time we'll be doing this for our classwork as well. You'll still have homework, and so you'll still have to input your homework through Google Classroom as well, but that I don't think I'll need to go over with you. That will still be the same. Okay. All right. So that's how you'll submit your classwork. Okay. And so what you'll also include on this form or on this piece of paper, what you will also include are some practice problems from your book that I will give you. Towards the end of the video, I'll assign a couple problems either from your book or some extra problems that I've come up with that you will do on this paper here, and you'll submit the whole thing at the end of the period. Yep. All right. So these are the extra practice problems that I was telling you about. What you'll do then is you'll work out these problems on the same piece of paper. These problems will be taken from your book or from what you'll get in your from problems that I've given you. Okay. Then you'll work out these problems on that paper, and then you'll submit all of it at the end of the period. So make sure you do this before the end of the period. Okay. And you'll submit it before the end of the period through Classroom. So I think what I'll ask you to do and turn in will be pretty simple, pretty straightforward. I will do the work for you, but I'd like to make sure that if you have any questions, make sure you ask them. Okay. All right. So to help you with those questions, then what I'm going to do is that I have these office hours set up for you. The times are the usual times after my engineering class from 3:15 to 4:15. We'll go as long as people are there. These office hours will be live, so you'll log on to Zoom, and I'll explain that to you in just a moment. You'll log on to Zoom, and then we'll be able to interact in a live manner. I'll be able to answer your questions and go through whatever issues you may have. At that time, you can also express your concerns about how the lesson went that morning, and so or afternoon, and so you'll be able to let me know at that point. Okay. All right, so how are we going to meet? We're going to meet through Zoom. Login information is right there for you. So I've given you the address there for you to log into. What you'll do is you'll go ahead and log in. Just enter that into the address window in your browser. It'll take you straight to our meeting site. And from there, then we can start interacting. You can ask your questions at that time. Okay, so I've given you that information. We'll be using this same ID for the entirety of however long we have to go on with this web interaction. Okay, so that's what you'll use, and that's how I'll go ahead and I'll conduct the office hours. So these meetings, these tutoring sessions will be live, and so please make sure you make use of it and log in and ask your questions. Okay. Okay. All right. So I think with that said, I think it should be pretty straightforward. I tried to make it as simple as possible. Our interaction should be as simple as possible online to eliminate any problems that may come up. And so if, like I said, if there are going to be issues, we'll work it out. We'll work it out together. We'll figure it out and we'll make it work for us. Okay. All right. So let's go ahead then and let's get started. I have at this point about a little under 15 minutes to present to you the new material. But again, like I said, I want to try to make sure that I keep the material down to about 25 minutes so that you can get the work done as well. Okay. So let's go ahead and let's take a look at where we left off with last on Friday, and then we'll continue on. Okay. Remember, with the balanced equation, we need to be able to interpret the balanced equation. We need to be able to look at the numbers, the coefficients, and understand what those numbers are telling us. We saw then that the balanced equation, the numbers tell us how to interpret in terms of atoms, the total number of atoms you start out with, the total number of atoms you end up with. We saw in that instance that the number of atoms should be the same. If you start out with a certain number of atoms, certain types of atoms, you should end up with the same type and the same number of atoms. That should not change. That's the law of conservation of mass. And we also saw then though, using the coefficients to interpret the equation in terms of atoms doesn't really help us to run the reaction itself. Remember, the goal here is to run the reaction, be able to take the numbers, take the symbols, and make sense of them and mix them together and form your products. That's the idea behind these balanced equations. That's what we learned back in chapter 11. And so what we want to be able to do then is to run the reaction. And you can't run these reactions at the atomic level. And so what do? We have to scale it up. And so the next level at which we can interpret these chemical equations is at the molecular or the particulate level, the not just the atoms, but the compounds themselves. And so when you look at the balance equation, the numbers, the coefficients also tell us the particles, the compounds, the number of particles to get together to make the product. So the coefficients also tell us that. But then again, we also saw on Friday that that's fairly impractical. You cannot isolate different particles. You can't isolate just individual particles, individual molecules, individual formula units in order to run a reaction. So that that also is impractical. That cannot be done. So what do we do then? We scale it up again. We make sure then that we have a way that we can interpret the equation on a macroscopic level. So we saw then that the balance equation, the coefficients from the balance equation, also tells us the number of moles that go into the chemical reaction itself, the number of moles of reactants, and the number of moles of products as well. And that's where I want to start out with here. The balance equation, remember, gives us the number of moles of reactants and products. And so if you take a look at this equation here, we see then that if we interpret this correctly, then the balance equation here tells us that you have a 1 in front of the nitrogen, a 3 in front of the hydrogen, and a 2 in front of the ammonia. Okay? What this is telling us then is that if you take one mole of nitrogen and you mix it together with 3 moles of hydrogen, you will obtain 2 moles of ammonia. So that's what the balance equation tells us. And we see here, just like with what we saw at the molecular level, the number of particles, the number of moles do not add up on either side, and we don't expect them to. Will that happen every once in a while? Yes, it will, but we don't expect that to happen. And so the coefficients here again tells us the number of moles of reactants and products that we have to mix together in order to run this reaction. Now, mole, remember, is Avogadro's number of each one of these particles. So we've scaled it up from, for example, a single molecule of nitrogen to Avogadro's number of nitrogen. Here, instead of just 3 molecules of hydrogen, we've scaled it up to 3 times Avogadro's number of hydrogen molecules. So we have a lot more working out here. Again, like we were talking about Friday, the only issue with this then is that we can't measure out moles. There's no device, no measuring device that we can use that will allow us to measure out the moles of a given substance. So what we have to do is we have to be able to convert this amount here, the moles, the amounts that we can measure out, amounts such as mass. We can measure out mass. We have triple beam balances that allows us to do so, or we can, if we can, convert this also into units of volumes, convert the moles into volumes, which we can also measure out because we have tools that allows us to measure that out. As of today, there are no measuring devices that measure out moles. And so the next thing we need to talk about then is how can we take this balanced equation here and interpret this equation in terms of mass and in terms of volume, which we can measure. Okay? And so we don't get this information directly from the periodic table, from the balanced chemical equation. We have to obtain it indirectly by doing a conversion, but we can do it because we learned how to do these conversions back in chapter 10. Okay? And so we got to take that material, take what we learned back in chapter 10 and apply it to what we're going to be doing here with balanced chemical, with reactions. Okay? All right, so let's go ahead and take a look at how we go about doing that real quickly and see what we can obtain here. Okay, so using this equation again, we know then that what we're starting out with is 1 mole of nitrogen. So let's go ahead and write that down. So we know we're starting out with 1 mole of nitrogen. Okay, based on the balanced equation, that's what we have. We cannot use moles in order to measure. We can't measure out moles, so we do our conversion. We do our conversion to mass and mass in grams. Okay, and I hope it's clear why we have to convert it to mass in grams. Okay, but how would we do this conversion? Well, remember, we did this conversion by using the molar mass. The molar mass for the substance here is nitrogen, and so this is a diatomic molecule. So therefore, then this would be 14 times 2, which is going to be 28 grams. And since we are starting out with moles, and we want to get to grams, we're going to go ahead and we're going to multiply by the molar mass, multiplied by the molar mass of nitrogen. Okay? And so we end up here with 28 grams of nitrogen. What this means, I'll get to in just a moment, but there it is. Now instead of moles, now instead of atoms, instead of molecules, instead of moles, we have then a quantity here that we can actually measure out and run. So we have that. We'll do the same thing with the hydrogen. Okay? From the balance equation, we're told that we have 3 moles of hydrogen to start out with. There it is. That coefficient there tells us we have 3. We need to convert that into grams because that's what we can use. So we can actually measure out this quantity. It's very difficult to measure out the quantity of mole, and actually we don't have any measuring device to do so. And so let's go ahead and do the conversion again. Since we want grams at the end, we're starting out with moles. We're going to multiply by the molar mass of this diatomic molecule, which means that it's going to be 2 grams of hydrogen for every 1 mole. Please make sure if this does not, if you don't remember this, you go back and you review it, or you come by and see me and you get some help with it. Okay. All right. So with that said, then you plug that in, and then you will get your answers 3 grams. And so what we have here is 3 grams of hydrogen. So we start out with 28 grams of, I'm sorry, that's why I need you folks here, 6 grams of hydrogen. Okay, so we start out with 6 grams of hydrogen, and so let's take a look at what this means for us here. Okay, so let me erase this real quick. Okay, so what this is telling us is then, if we start out with 28 grams of nitrogen and 6 grams of hydrogen, we're going to produce a certain amount of ammonia. Now, there's 2 ways we can get that final amount, and I'll do it the way that we've done it here for right now. Okay, so what the balance equation tells us then that we will produce 2 moles of nitrogen. Okay, so when we mix 1 mole of nitrogen with 3 moles of hydrogen, we'll get 2 moles of ammonia. But those 2 moles of ammonia are also equivalent to a certain mass of ammonia, which we can work out by multiplying by its molar mass, which is in this case then 17 grams of ammonia over 1 mole of ammonia. Okay, we end up with 34 grams of ammonia. So what we've done here is we've calculated for the amount of nitrogen and the amount of hydrogen that we need to start out with, and the amount of ammonia that we expect to produce based on these amounts here. Okay. All right. So hopefully you can get that, but hopefully you recognize here also that there's a simpler way to go about getting the final amount of product here. By recognizing and remembering the law of conservation of mass, and the reason why we call it law of conservation of mass is that the masses that you start out with has to be equal to the mass that you end up with. Okay, so that's the whole idea behind the law of conservation of mass. So if you add up the amount of nitrogen that we start out with the amount of hydrogen that we start out with, they should add up to the amount of ammonia that you end up with. So that's the whole idea behind the law of conservation of mass, and that's what you should be able to do. So again, if you want to do it the easier way. So there's 2 ways you can get this final answer here. You can actually just take the number of moles here, or you can just add up the amounts of the reactants that you started out with. Okay. All right, so there it is. So the coefficients don't give us directly the information about the mass quantities. We have to do a simple conversion. We have to do a moles to mass conversion in order to get that done. But again, that's a fairly simple conversion that allows you to determine the masses of the reactants and the masses of the product that will form. And so like I said, the reactants, the masses of the reactants, the masses of the product have to be equal to preserve this law of conservation of mass. And if you keep that in mind, that should help you. Okay? All right. So we did that. Let's go ahead then. We did the masses there. Let's go ahead then and let's talk about, let's talk about this here. All right, so masses are fine. Okay, we can measure out masses. Masses is a pretty, we have the instrument, we have the triple beam balances, we have the electronic balances, we have the tools to measure out masses. But if you notice here, these are all gases. These are all gases here. And so it's very difficult to measure out gases and capture those gases and put them on a scale. So gases can be more easily measured by volume. Okay, so by volume. And so what I'd like to do here really quickly is to see then how we can obtain volumes from these moles here. If we remember then that we were able to convert moles to mass, the molar mass conversion. Remember back in chapter 10, we were also able to convert moles to volume in liters of a gas at STP by using the molar volume of 22.4 liters per mole. Okay. So if we have this reaction here, and if it is run at STP, and that is important, folks, you have to remember that if this is not at STP, we cannot do this. But if this reaction now is run at STP, we can go ahead and carry out this next conversion here that will allow us to determine the volumes of these gases rather than the masses, because it's, like I said, it's easier to measure out volumes and determine volumes of gases than it is to determine their masses. Okay? So from the balanced equation, then again, we know that we have 1 mole of nitrogen. Okay? And so therefore, then if we want to convert it to liters like we did back in chapter 10, okay, we can go ahead then and multiply by the molar volume of nitrogen, which is 22.4 liters, okay? And then we end up with 22.4 liters of nitrogen that we start out with. Okay, so what this is telling us is that if we start out with 22.4 liters of nitrogen, and we combine it with a certain volume of hydrogen, we're gonna produce a certain volume of ammonia. So what's the volume of hydrogen that we have to mix in with this 22.4 liters of nitrogen gas? Well, we know then from the balanced equation, we have to start out, we have 3 moles of hydrogen gas, okay? We wanna find out what the volume is of that hydrogen gas. And here we will multiply by, again, the molar volume of hydrogen gas over 1 mole. Sorry about that. And so we'll end up here then with a volume of 67.2 liters. Okay. All right. So with that said then, we have, what we're saying is that we mix together 67.2 liters of hydrogen with 22.4 liters of nitrogen, we're going to produce a certain volume of ammonia. So let's go ahead and find out how much ammonia is going to be produced. So we have then 2 moles of ammonia, okay? And we want to find the volume of that, ammonia gas. We'll multiply again by the molar volume, E over 1 mole. Okay. And we end up here with 44.8 liters. Okay. So what is this telling us? This reaction is telling us then that if we mix together 22.4 liters of nitrogen with 67.2 liters of hydrogen, we will produce 44.8 liters of ammonia. Now, if you notice here, the law of conservation of mass does not apply to volume because it's conservation of mass. It doesn't apply to volume, and that the starting volume and the volume you end up with are not the same. Okay? They will not end up equaling each other. Okay? And so that's another way that we can go ahead and use the balanced equation in order to find quantities that are measurable. Okay? And so again, we can use the coefficients to find the volume in units of liters. Okay? And that you have to remember then, in order to do so, we have to check to make sure that the conditions are at STP and that we're dealing with all gases. They have to be gases. Okay. All right, very good. Let's go ahead then, and I'd like you to work out number 7 here. I'm going to give you about a minute or so to answer the questions here. So please make sure you write this down on your paper, okay? And then go ahead and answer the question. And then in about a minute, hopefully it'll take you about a minute or so to get this done. Input your answers onto Edpuzzle. And then I'll go ahead and work out the answers with you. I'll work out the answer with you. Make sure you write down the solution on your paper as well. Okay, so take about a minute to get this done. Okay, let's go ahead and let's take a look at this problem then, and let's take a look at what they're asking you to do. So in this particular problem here, they're asking you to find then, do everything essentially. Find the number of particles, number of moles. They're not asking you about the atoms, so don't worry about that. But let's go ahead then and do that anyway. But I'm just going to make sure you see then we'll total up the atoms. So we want to be able to interpret this equation in terms of total number of atoms, okay? Total number of molecules. And remember, molecules, again, we were using this in a very generic way to just indicate the number of particles. We're going to interpret this in terms of moles as well, the molar level. Okay. We want to find the masses. Okay. And also the volumes as well. Okay. All right, so let's go ahead and do this here. First thing we have to do is check to make sure that the equation is balanced. If the equation is not balanced, we cannot do anything about this. Okay, so make sure you always check to see that the equation is balanced. So if you balance this equation out correctly, then the coefficients then should be 2, 5, 4, 2. So you need to make sure you always start out, check to make sure that the equation is balanced. Don't assume that it is. Always make sure that you balance the equation. Okay. All right, so with that said, then what I'm gonna do is I'm just gonna quickly total up the atoms here. Then if you notice, basically what we're doing is we're keeping tally, keeping track of the atoms here. If you count it up then, and I'm just gonna give you a total, we're gonna have 18 total atoms. On the left, you can kind of see it here, you got 10 here, 8 here, okay? Which means then you should have 18 total atoms on the right. Okay, so go ahead and write that down, okay? In terms of molecules then, make sure you keep this in mind, what we're being told here from the balance equation. We start out with 2 molecules of ethine, C2H2, 5 molecules of oxygen, okay? And we would produce then 4 molecules of carbon dioxide and 2 molecules of water. Okay, so again, that's molecular, so that's the total there. Okay, and if you notice here, the two sides that are not equal, you start out with 7, you end up with 6. Okay, so make sure you keep that in mind that you don't always have that happening. All right, so with that said, then let's scale it up a little bit. Now let's talk about moles. You have then, if you take a look at the Dot's equation, then we have 2 moles of ethine, C2H2, combined. We combine that with 5 moles of oxygen. And if we do that, we produce then 4 moles of carbon dioxide and 2 moles of water. And so if you notice here, the number of molecules, the number of moles directly correspond to the coefficients. Okay? And so we don't have to do any calculation there. The number here, the coefficients give us the number of moles and number of molecules directly. Okay, that's not going to be the case then for masses. Okay, and so for masses, then let's go ahead and let's work this out here. I'll work this out for you. Let me go ahead and erase this, and then let's work this out. Please make sure you have that. I'm gonna go ahead and erase this here on the slide here. Let's work out what we have here. Okay. Okay. So we know then that we had 2 moles of, I'm sorry, 2, let me write this back in, 2, 5, 4, 2, 2, 5, 4, 2. All right, so we know then that we have 2 moles of ethine, C2H2. We're going to convert that into grams of C2H2, right? And so the molar mass of ethine then is going to be 26 grams per mole, okay, which gives us then here 52 grams of C2 ethine, C2H2. Okay, doing the same thing for oxygen, then we have 5 moles of oxygen. Find the grams, the mass of oxygen. Okay, oxygen then is a diatomic molecule, so that's going to be 32 grams O2 for every 1 mole. Okay, which gives us then 160 grams of oxygen. So we start out with 52 grams of ethine, we mix to that 160 grams of oxygen. What we'll produce here then, let's go ahead and find out here. We have 4 moles of carbon dioxide. Find out what the mass of carbon dioxide equivalent to that is. And so We'll multiply by the molar mass of 44 grams per mole. Okay, we end up with 176 grams here of carbon dioxide. And then to find out the mass of water, it's one of two ways you could do it. You can go ahead and add these two up here. You remember, masses have to add up. Add these two up, subtract this amount from that, and you'll get your mass of water. But I'm going to just go ahead and do the conversion here as well. So therefore, we need grams of water. Okay. It's going to be 18 grams water per mole of water. And we end up here with 36 grams. Okay. And again, like I said, the total masses of reactants and products have to be equal to one another. Okay, so that's how we get the masses of the reactants and products. Okay, finally, let's go ahead and take a look at how we obtain the volume, and I'll finish up with this here. My time is running out of time here, and so I got 2, 5, 4, 2. Okay, and so again, 2 moles, and I'll work out a couple of these. I'll work out this fairly quickly for you. Of ethyne, we want liters of ethyne. Again, we'd multiply by 22.4 liters. Oh, sorry, excuse the handwriting. Okay, and so we end up here with 44.8 liters. Okay, so that is the volume of ethyne. 5 moles of O2. Okay, at the volume of O2. Again, we're going to use the same number. This is still 22.4 liters, even though the gas is different. Remember, Avogadro's law tells us that it doesn't matter what the identity of the gas is. 1 mole of any gas at STP or at that particular temperature pressure will always be this volume right here. Okay, so that said, then we'll get 112 liters of oxygen. Okay. Doing the same thing for carbon dioxide. And that's why I think solving for the volume is very simple, because you're always multiplying by the same number. As long as, remember, the reactions run at STP, you should be fine. So we're going to go ahead and plug in 22.4 liters CO2 over 1 mole CO2. And that's going to give us 89.6 liters. Okay, CO2, sorry. Okay. And then finally, we have 2 moles of water. We want the volume of water. Okay. Again, 22.4 liters. Water, 1 mole of water to give us 44.8 liters. And if you notice here, the volumes do not add up. Those are our final volumes. Okay. All right, so please make sure you write down these solutions here. Write down these solutions onto your paper, and then what we'll do is you'll submit this after you do the problems. I'll give you the problems in just about a minute. At the end of this video here, work out those problems. They will be from your book. Work them out, and then work them out on the same sheet of paper that you wrote these problems down on, and then make sure you submit it before the end of the period. Okay. All right, folks, that's it for today, and I will see you tomorrow. Okay. Have a good day.